Our fourth segment on fluid statics is Pascal's principle. And Pascal's principle states that in an enclosed container that contains fluid, the pressure is equal everywhere. So if you push down on the fluid in one direction, that will increase the pressure, and that pressure will then be translated all throughout the fluid. Which means that in a situation like this, where we have a hydraulic lift that tries to push up a car, when we push on the other side where the piston is, we can actually cause the car to go up. And the way that works is this, that we can say that the pressure on this piston right here, at P1, must equal the pressure on the other side, P2. So we can say that the pressure everywhere in the liquid is equal to each other. And so the question then becomes, how much force will be required to lift up a 2,000-pound car? And of course, that is something we would see at the nearest service station, for example. All right, so since pressure is equal to force times area, pressure is equal to, or not force times area, but force divided by area, we can then say that force is equal to pressure times area. So in this case, we know that pressure can be expressed as force divided by area, so we're going to then write that force at piston 1 divided by area at piston 1 must equal the force at piston 2 divided by the area at piston 2. And since we're looking for F1, we'll then go ahead and bring A1 over here. Excuse me, so the force at 1 is equal to the force at 2 times A1 over A2. Now, what is the force over here? The force over there is, of course, equal to the weight of the car. So this can be written as the weight of the car times the ratio of the cross-sectional areas of the two pistons. And since A1 is much smaller, 2 square inches, versus A2, which is much bigger, 100 square inches, you can see then that you need a lot less force to lift up a car. And so this, therefore, is equal to 2,000 pounds, the weight of the car, times the ratio of the areas. The cross-sectional area here would be 2, divided by the cross-sectional area there would be 100. And so that would be equal to 40 pounds of force. So, which means that with a very small push of 40 pounds, you can lift up a car that weighs 2,000 pounds, just because of the ratio of the cross-sectional areas of the two pistons on both sides of this tank. So it's pretty amazing. Now, of course, they don't do that with a physical push down like that down the piston. What they typically do here is they connect this to a compressor, and then they pump air into here. And so by pumping air in here, they can keep the air flowing, and you just keep pushing the car up like that. And that's how these hydraulic lifts work. All right, but that's how you utilize Pascal's principle to solve a simple problem like that.